Hey guys, so today we're going to talk about perfect squares and factoring. So some of the trinomials that you're going to see today are going to be considered perfect square trinomials. So basically they were in the form a plus 4 quantity squared, or 2x minus 3 quantity squared, like a plus 4 times a plus 4, or 2x minus 3 times 2x minus 3. So they were in that form. So how do you know if it's going to be a perfect square trinomial? Well, if you look here, if it ends up being in the form a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, then we know that it is a perfect square trinomial. So the example that they've got here, so how do you know, right? So look at the squared term. So the coefficient here is 1. 1 is a perfect square, so that works. And the constant term, is it a perfect square? It is. And it has to always be plus, positive, right? Then you want to look down here. This is 8. So the square root of 1 is 1. The square root of 16 is 4. What's 1 times 4 is 4. Then double that, and you get the 8. Confused? Let's practice it and see what happens, okay? So let's go down here. The very first set of directions just says, determine whether or not each trinomial is a perfect square trinomial, and if it is, factor it. All right, well, first I got to check here. That's a perfect square. Yep, that's a perfect square. All right, if I take the square root of 64, I get 8. The square root of 1 is 1. 1 times 8 is 8. And then double it, 8 times 2 is 16, which is what I have in the middle term. So yes, it is a perfect square trinomial, yes. And so when I factor it, okay, then it's going to be, let's make the box. So I'm going to do x squared there, 64 there, and it's going to have to be negative, right? Negative 8x. How do I know? Because this is negative. So then when I factor it, I end up with a negative 8 here, and an x, and a negative 8 there. So it's x minus 8 times x minus 8, or the quantity x minus 8 squared. Okay, let's look at number 2. All right, so that's a perfect square, and that is a perfect square. So that's a 1, and that's a 5. When I do 1 times 5, okay, I get 5. When I double it, 5 times 2, yep, I get 10. So this should be a perfect square trinomial, so I'm going to write yes, and then let's factor it. So how's that going to be? So I've got m squared, I've got 25, okay, and then the square root of 25 is 5, so that'd be 5 m's, and it should be positive because this is positive. So when you factor it out, that's a 5, that's an m, and another 5. So it'd be m plus 5 times m plus 5, or m plus 5 quantities squared. I think I forgot to highlight my yes over here. Sure did. All right, what about number 3? Is that a perfect square trinomial? Well, 1p squared is a perfect square. All right, and 64 is a perfect square. The square root is 8. So 1 times 8 is 8. And then 8 times 2 is 16, not 8. So is this a perfect square trinomial? No, then we do not have to factor it. Okay, that's it. All right, the bottom section, factor each polynomial if possible. So some will be perfect squares, trinomials. Some will be a difference of squares. It really just depends. Some will just be regular old trinomials. If it cannot be factored, then we write prime. So this is just a hodgepodge. All right, let's look at number 4. So we've got 98x squared minus 200y squared. So I'm pretty sure there's a common factor here. So we can pull out at least a 2, maybe another number. So let's see. When I do 98 divided by 2, oops, I get 49 x squared, and that would be minus 100 y squared. All right, this is like the previous lesson, right? This is a difference of squares. So we know that this is going to be 7x minus 10y times 7x plus 10y. So we learned that in the previous lesson. And don't forget that too. All right, go to number 7. So I have 25c squared minus 10c minus 1. There's nothing I can take out of all of them. So let's just go ahead and factor it like we normally would. So I'm going to do 25 times 1, which is 25. And then I'm going to list out all the factors of 25. 1 times 25 and 5 times 5. And I'm looking for a pair that is going to give me a 10. So that would be 5 and 5. So let's make that box just like we did in earlier lessons. So I'm going to have the 25c squared here, the negative 1. I need a negative 10, okay? So that would be negative 5c and a negative 5c. Now let's pause here. Negative 5 plus negative 5 is negative 10. But when I do, oops, oh, I'm so sorry. When I do a negative times a negative, do I get a negative here? No. If I do negative times a negative, I'm going to end up with a positive. So this is actually going to end up being prime. We're not going to be able to factor this one because of the signs. Let me show you what I mean. So here I end up with a negative 1. This would be 5c. That's another 5c. And this is another negative 1. So 5c minus 1 times 5c minus 1 right there is going to make a positive 1 as a constant term, not a negative 1. So actually this one cannot be factored and is prime. It looked like it was going to be a perfect square trinomial, but it's actually not. Okay, let's look at number 10. So I know 16, 48, 36, I can pull out a 4 from all of those terms before I do anything else. So let's factor a 4 out. That leaves me with 4m squared plus 12m plus 9. Oh, I can actually pull out, nope, nothing else. All right, so now I'm going to try and factor out that 4m squared plus 12m plus 9. So 4 times 9 is 36, and then I'm going to list out all the factors of 36. 2 times 18, 3 times 12, and 4 times 9. And I want a pair that would give me 12. Oh, and 6 times 6, y'all. Okay, and I need a pair that would give me 12, which would be the 6's. So let's go ahead and write that. So that's 4m squared, that's 9, 6m and 6m. So that would give me positive 12, and if they're two positives, positive times positive is positive. Okay, so this is going to work. So this is going to give me a 3, this is a 2m, this is a 2m, and that is a 3. So bring down that 4 you pulled out, times 2m plus 3, times 2m plus 3, so that's times 2m squared. So it was actually a perfect square trinomial. And we didn't even recognize it right off, or maybe you did, but you can still use that box method to help you. Let's look at 13. Okay, so is there anything that we can factor out? No, there's nothing that we can factor out. So let's just go ahead and do it the long way. So we'll do 36 times 1, which is 36. Oh, and I've already got the factors of 36 written up there, but I'm going to copy them down again so that I can circle the pair that's going to give me a negative 12x. So let's back up a minute. Oh, no, never mind. A negative 12. So 6 plus negative 6 plus negative 6 would give me negative 12. A negative times a negative is a positive, so this is going to work, I think. Let's double check. So we're going to make our box. We got 36x squared and a 1 there. We need these to be negative 6x's. So here you're going to take a negative 1 out. Since that negative sign is is right up against here, you pull out the negative there. This would be a 6x. This is a 6x. And again, a negative 1 there. So it becomes 6x minus 1 times 6x minus 1, or 6x minus 1 quantity squared. All right, your turn. I want you to do 5, 8, 11, and 14. And go ahead and let's write the word skip right here across 6, 9, 12, and 15. So pause the video and do that middle column now. Okay guys, welcome back. Let me zoom in just a smidgen. I want you to go ahead and pause the video and check your answers to 5, 8, 11, and 14. Okay, all right, we're going to go to the next page. And this next page is just solving equations with those perfect squares. All right, and one of the important things they're talking about, when you're taking the square root of any number, it's always plus or minus. So there's 2 roots to every number. There's the positive square root and the negative square root. For example, over here, when they were doing the square root of 64, the square root of 64 is 8, right? Because 8 times 8 is 64. Well, it's also negative 8, because if you do negative 8 times negative 8, you also get 64. So when you're taking the square root of any number, remember that there's 2 possible square roots, the positive root and the negative root. So keeping that in mind. All right, so we're going to solve equations, okay, of that form. So let's just jump right in here. So let's look at number 1, x squared plus 4x plus 4. So that is actually one of those perfect square trinomials. So it becomes x plus 2 times x plus 2, or x plus 2 quantity squared. All right, so when I solve this, if I take the square root of both sides, that leaves me with x plus 2 equals plus or minus the square root of 0. Well, 0 is a special case, right? Because the square root of 0 is 0, and you're not going to put that plus or minus because 0 is neither positive or negative. So when I solve this, x is equal to negative 2. So this is actually a special case. This just has negative 2 as its root. Let's do another one. Let's go to number 4. X squared plus 10x plus 25 equals 0. So this is another one of those perfect square trinomials. It's going to end up being x plus 5 quantity squared. Okay, take the square root of both sides. So x plus 5 is equal to the square root of 0, which is 0. So x is going to be negative 5. And that's your only root. We call that a double root. Oops. Let's look at number 7. So number 7 may be a perfect square trinomial, right? So when you look at that one, let's see, that would be, what is that, 5k? That's a 2. 5 times 2 is 10. Double it, you get 20. So it should be a perfect square trinomial. You can always go the long route. So this should be 5k plus 2 in parentheses squared equals 0. When I do the square root of both sides, I end up with 5k plus 2. Well, the square root of 0 is 0, and it's only 0, right? So 5k equals negative 2. K would be negative 2/5. So the only solution here is negative 2/5. Now, 10 is different because that one is not equal to 0. It's set equal to 25. But look at this side right here. This side right here is a perfect square trinomial. So we don't need to worry about subtracting 25 on both sides and then trying to factor it. This is the same as x minus 3 quantity squared. So if I take the square root of both sides, I end up with x minus 3 equals plus or minus the square root of 25. So I have 2 solutions. X minus 3 is equal to positive 5, or it's equal to negative 5. Okay, because the square root of 25 is either 5 or negative 5. 5 times 5 is 25, and negative 5 times negative 5 is also 25. So here x would be 8, and here x would be negative 2. So I have two solutions, negative 2 and 8. Let's do another one. Let's do number 13. So this one is already written in factored form for us. And 49 is a perfect square, so I can just go ahead and take the square root of both sides. So x plus 3 is equal to plus or minus the square root of 49, which means x plus 3 is equal to 7, or it is equal to negative 7. Here x would be 4. Here it would be negative 7 minus 3, which is negative 10. So my solutions are negative 10 and 4. Okay, same thing is happening here. So 2x plus 1 is equal to plus or minus the square root of 1. So 2x plus 1 equals positive 1 or negative 1. So this would be 2x equals 0. So x would be 0. 2x equals negative 2. So x would be negative 1 here. So my answers here are negative 1 and 0. Okay, we'll do one more together. Again, now this one is a little tricky, right? So this would be x plus 1 is equal to plus or minus the square root of 7. And the reason it is tricky, if you do the square root of 7, you're going to get this long decimal number. 7 is not a perfect square. So I'm going to write x plus 1 is equal to the positive square root of 7. Actually, I'm not going to even write that. I'm just going to solve it, okay? So if you subtract 1 on both sides, you'd get plus or minus the square root of 7 minus 1. Or another way to write this is negative 1 plus or minus the square root of 7. So meaning you do negative 1 plus whatever the square root of 7 is, and the other answer is negative 1 minus whatever the square root of 7 is. This is a typical way to leave this, okay, since it's irrational. You're not going to have very many of those instances. All right, I want you to do 2, 5, 8, 11, 14, 17, and 20, and we'll skip the third column. So basically, you're going to pause the video, and I just want you to do that middle column. Okay guys, so welcome back. I want you to go ahead and check over your answers here. So here's problems 2 and 5. And then you can see 8 and 8, 11, and 14. And then 17 and 20. As usual, if you have questions about any of these problems, please bring them to my attention so that I can assist you. You are welcome to work on the problems that you've skipped over if you need additional practice. Okay, so now that you've finished this, go ahead and turn this assignment in and work on your independent practice.